Alright, here's our next video. This one's going to be my first shot at probably doing some editing too, because I'm going to do a little short burst and then put them together. And the radio just fell over. Anyway, it's this little radio here. It's a Philco model 48206, and I picked this one to work on because it's going to be relatively simple, because the main thing I want to do with this radio is, once I get it restored, is to use it for a troubleshooting video and show you how different troubleshooting techniques, how to go through it, how to figure out what may be or may not be wrong with the radio, what you might find, and things like that. Since I have the SAMs, and it has a very excellent voltage chart here, as well as a resistance chart, and I'm going to take you through, as we do that, once it's restored, the differences in how you use these. Here's the radio. It's not a bad little radio, low AM radio. It's a All-American 5. It's got some cleaning it's going to have to be done to it. And the dial strings broke on it, which I know some people have problems with dial strings, and they can be rather complicated. I already cut the power cord off. Not only is it cracking, but it's had a repair at one point in time, which is not exactly probably safe. This radio, like typical Philcos, will also have some interesting things about it, because it's got Locked-Hole tubes, and that's something I want to talk about. They can cause you a lot of problems sometimes, that just because of the fact that their sockets and pins get dirty and need really a serious attention to cleaning. If you don't, you'll have intermittence, or even the radio may not even want to work. Now, the underneath side of this radio has been worked on. These three guys here are replacements. The original electrolytic that would have been in it is shown in Sam's picture of the radio, and it would mount right here. It would have been a cardboard tube and 3 sections, ground coming out this way and the other wires going over to the rectifier tube. Instead, someone has replaced that and took it out, which I wish they wouldn't have, but it's long gone. The interesting thing is I always love this when people work on radios. In the past, some of them, this one came loose. It should be going here. This is the ground, or the B minus area connection. I don't even know why it was twisted around that way, but it was also put in the wrong place. If I can find me a pointer here, and if I can come in close enough, it's connected to right here, and it should have been connected to here. This is filament. That's an AC signal. They were connecting a DC capacitor onto an AC line there, and I'm sure it probably didn't seem to work right. And they may have been ones that actually desoldered it. Either way, it wasn't soldered in too well. They made a mess of this connection. We'll clean all this up. But anyway, it should have went here. Instead, they put it on the filament, and that was definitely wrong. So I'm going to stop this right here, and in the next video I'll show you progress and stuff, and then eventually we'll get done with it, and then we'll do a troubleshooting and talk about the different things you might run into. So to you, it'll be just like no jump or stop at any point. You'll just things will magically change. Okay, here we are. Here's our chassis that I've pretty well dismantled. I got a little more cleaning to do on the rust. This is just the first pass of running some navel jelly. We'll run a second pass through it and try to get her a little more cleaned up. Stripped her down, pulled all the parts out that are definitely going to be replaced. There's still a few. This resistor has to be replaced, and that one there, and this one right here. The rest of them are still actually good. But I wanted to take this moment to show you something. If you look at this socket here, this is the output tube. And since it gets so hot, it has pretty much warped up this top cap, and then part of it's broke off. Now, these are easy to fix. If you've got some sockets already, you don't have to replace the whole socket. They actually will come out by squeezing this and bringing it out. Now, a lot of times these are connected to ground, and such as these are here. So you'll have to disconnect them, and they can be sometimes a pain to get out, which we'll probably see how hard that's going to be. But you just squeeze them good and get them to come out, and then they just pop right out, just like that. Now, they've got these little tabs here, and a lot of times you have to get really down on them to squeeze those in. You can see that, but once you get them out, I had some old sockets, and that's where I got this one from. The other thing too is, at this point, if you was in the process of, say, replacing some parts or something, and you end up getting them twisted off, and you break one of these off here, that's not a problem, because these will come out once they're completely cleaned off of solder, or if they're broke, they'll shove right out through the top here once that piece is out. So now, how to put them back in is real simple. They just shove in. Here's your lock, or your locating pin area right here. Try to get, hopefully it's showing up pretty good. But it's right here. That corresponds to this little area right here. So they can only go in really one way. So you line that up. Make sure that the little keeper is in the right place. Get that pretty well lined up. And sometimes you have to kind of squeeze them together just a little bit to get them popped down, and then they snap right into place. As you can see right there. And it's back into place, solid. And I'll be able to hook my wires back up and my grounds back up, and then go ahead and continue from that point. Now, these loctals are notorious for giving troubles. And especially, I hate to pick on any brands, but especially Philco tubes, because for whatever reasons, they seem to think that their pins need to be a little bit shorter than everybody else's. And I don't know if you can really see this real good, but this is a GE tube, replacement tube, and this is the genuine Philco, the Philco Loctal, and the pins are actually shorter than on the GE. And pretty much, if it was an RCA or any other brand, you'll see that the pins are a little bit longer. When these are in place, the well, somewhere around an eighth of an inch is all it's really going into the socket. Maybe a little bit more than that. Where these you'll get not quite double that, but it'll get in a little bit further. Now the one thing, I usually use one of these little files to clean the pins up, because you can just start working your way around them. You can use sandpaper or anything else. This one's about wore out, but I got a couple more. These are, you can get these at an automotive shop. All they are is a point file. Back when cars used to have points. And which they also work really nice if you're working on relays or anything like that, that you can clean them up, the points on those. To clean the pins, or the sockets, this is just all it is a tip cleaner. You can pick these up at any welding supply store. They're for your torch tips. They come in various sizes. You'll probably never ever use the little dinky ones. They don't cost much. I mean, there are some that are real high priced. Probably they might last longer. But these don't do too bad. I think it costs like $5 or $6. And now the one thing is on these, especially on these style, some of these open completely open, some don't. And these tip files, you probably can't see it, but the actual file stops right here. So you need to take a pair of decent dikes or something to cut that off, because these bottom out, and you won't be able to get down as far in. And all you got to do is just go in and just run back and forth just a little bit, and they'll clean everything out. A little bit of dirt on them. And every once in a while just kind of brush them off. And just go through all your entire sockets. Now these don't get big enough to really, you could clean these here. I generally use like pipe cleaners and with some solvent or something to clean your octal sockets. But these also work real good on your miniature, like 7 and 9 pin sockets. They work real good on cleaning those too. So anyway, just some various tips on doing stuff like that. This will be probably part 1 of this. In the next part we'll have some parts in here and stuff. I'll probably go over some other things that stuff I've replaced, and show you different points on that. One other thing about this, when I started taking out the electrolytics, if you remember, they were soldered down around this area here. Of course, the one was hooked wrong, but the other 2 were hooked up correct. One was hooked here on this coil, and then the other one was hooked over in here. The one was loose. I went ahead and just cut. That's where they were hooked, right here. I just cut this in because I wasn't going to mess with trying to get them off that resistor, since I was going to replace it anyway. But when I did, this is one of them that I cut out that was actually soldered down here to that mess that looked like a real terrible mess. And unfortunately, I doubt the camera will get close enough to really show this. But just this very little bit of tip was all it was actually soldered. And when I cut this in, it just popped loose. It looked like you tried bending it to fit in there, but around the thing, but it sure never did get soldered. I just get tickled about some of that. I pulled radios apart that when I pulled the chassis out, parts fall out. So anyway, as we start putting it back together and stuff, I'll make another video and show you where I'm at. And then when we're done, this radio, the way I'm planning on probably doing this is I not only want to use it as a means of teaching and showing you how to go through a troubleshoot a radio. I'm going to create problems in it by leaving certain, I'll solder one end of like capacitors or resistors, but I'll leave the other end where I can easily disconnect it, and show you, different things like that and what might run into problems. Plus, as far as our tube theory and radio theory, one of the most interesting parts is trying to understand how the detector works. So this radio is going to be great for doing that, and hopefully, if everything works out right, we'll try to use the scope to show you a wave. I'll send a clean signal into the radio, and we'll show you what it looks like on both sides of the detector. You can see the audio and see what the detector does, and be kind of just hopefully a good learning tool. So this will conclude part 1, and thank you for watching, and thanks for comments. I haven't got back to some of the comments on the previous video. I will get back to them. I just kind of got engrossed in cleaning this thing up, so I will get back to them, and thank you.